Now that we know how to assign oxidation numbers, we're going to learn how to balance by half reaction method. This initially is a little confusing, but what you do is you follow this little checklist and you do it one by one and have faith that it'll work out. One question students always ask is, when do I know to do certain things? Well, the directions will literally say balance by half reaction method, and you know what to do. With redox reactions, there's a transfer of electrons, and not only do we have to balance the masses with the correct number of atoms on each side of each element, we also have to balance the charges and the electrons, and therefore we have to use this method. So first thing is we're going to determine what is oxidized and what is reduced and split into the two half reactions. One of the half reactions is the reduction half reaction, and the other one is the oxidation half reaction. Looking at this reaction here, we could start by assigning oxidation numbers. We have a 0 for the iodine, we have a -2 for the oxygen, we have a +4 for the lead, a +2 for the lead, a -2 for the oxygen, and we have a +5 for the iodine. The iodine goes from a 0 to a +5, so the iodine is oxidized. And then the lead goes from a +4 down to a +2, and therefore it's reduced. We always have something oxidized and something reduced. However, because of law of conservation of mass, we can pretty easily separate these two. So if I start off with the lead, just randomly picking one of them, I'm pretty sure the half reaction is the lead's going to turn into the lead +2. I don't think the lead is going to turn into the iodine. That's not a chemical reaction, that's a nuclear change. So that's one of them. This means that the other half reaction would be the iodine going to the iodate ion. Now, we do this one at a time, balancing them one at a time. So I'm going to get rid of this guy for a second and start with this one and then go through my checklist. We're going to balance everything other than hydrogen and oxygen. One lead and one lead. Okay, did that one. Now we're going to balance all the oxygens with water. Water has one oxygen, so if we need 3 oxygens, we add 3 waters. There's 2 oxygens on the left, so we need 2 oxygens on the right. They come as water, so we write that down. Balance all the hydrogens with H+. We'll just put that in there. By the way, H+ represents a strong acid. We have 2 sets of 2, so that's 4 all day. So we put down 4 H+ on this side over here. This is our glorified checklist. So now we're going to balance the charges with electrons. You need to count carefully here. We can mess this up. So here we have 4 + 1, so that's a +4. This is a 0. Here we have a +2, and here we have 2 times 0. So we have a +2 equals to a +1. They don't have to equal 0, but they have to equal each other. So I'm going to add 2 electrons to the left-hand side. Squeeze this in here a little better. And we just represent it like an E-. That is a balanced half reaction. Now I need to go grab my other half reaction. So I'm going to put the iodine here equals to the iodate on this side. Now back to our checklist, we need to balance everything other than hydrogen and oxygen. That's number 1. So I'll put a 2 in front of the iodate because we have 2 iodines on the left side, so we need 2 of them on the right side. So I now balance everything other than hydrogen and oxygen. The second step is balance the oxygens with waters. So I'm going to put down water on the left side. I got 3 oxygens, so I need 3 waters. So now I have the oxygens balanced. Now we have to balance the hydrogens with H plus. We have 3 groups of 2, so that's 6 total. So I need 6 H pluses on the right. Got that checked off the list. It's just one by one in that order. Now we need to add the charges up and balance it with electrons. I have a 3 times 0, which is 0, plus a 0, which I'm pretty sure is going to be a 0 on the left side. We have 2 times the minus 1, so that's minus 2, plus the 6 plus, and therefore it's a 4 plus on the right side, a 0 on the left side, which means I need 4 minuses on the right side. So I'm going to add 4 electrons to the right side. All this junk up here. Now I got my second one. My second half reaction is balanced. It says add the 2 half reactions, making sure the electrons cancel. If they don't cancel, we'll have to add coefficients to one or the other, or both. And then the one after this says if it's in a basic solution, it will tell you if it's in a basic solution. You don't have to worry about that. We are not, so we'll deal with that later. But you would add as many hydroxides as there are hydrogens. If you had 4 hydroxides because you had 4 hydrogens, that would make 4 waters, because an OH minus and an H plus is a water. But what you do to one side, you'll have to do to the other. So if you add 4 hydroxides to one side, you have to add it to the other. That's only if it's a basic solution. So we have 2 electrons here and 4 electrons here. The electrons have to be on the opposite sides. So being on the left side designates that it's a reducing half reaction. Being on the right side designates that it's an oxidation half reaction. If you happen to balance them and they're both on the same side, you did something wrong, because they have to cancel. Well, how can 2 cancel with 4? And the answer is, well, it doesn't by itself. So what we'll do is we'll multiply this whole thing by 2. Multiplying the whole thing by 2 means that you're going to have 8 of these guys. You're going to have 2 of these guys. You're going to have 4 electrons. You're going to have 2 lead 2s, and you're going to have 4 waters. Now we're going to add the 2. Just like anything in algebra, or like when we did Hess's law, things on the same side will add, things on opposite sides will cancel. And there's often a lot of things that will cancel. So first of all, the electrons are going to cancel. I have 8 hydrogens on the left and 6 on the right. 6 will cancel with 6 of the 8 to leave 2. So I got 2 H pluses here. The lead oxide is not going to cancel. You got 2 of them. Here we have 3 waters and we have 4 waters. 3 will cancel with 3 of the 4, leaving you 1. We also have the iodine on the left side. We're going to have the 2 iodates on the right side. We're going to have the 2 leads on the right side. Then we're going to have a water. And that's it. Everything else canceled. Electrons are gone. And that's what you end up with. That is a balanced half reaction. Let's do one more real fast. We're going to start off with this tellurium ion. And what do you think it goes into? I'm pretty sure it goes in tellurium, not the nitrate. So rule number 1, we're going to balance everything other than hydrogen and oxygen. One of these, one of these. All done. Rule number 2, balance all the oxygens with water. So we're going to have 3 H2Os on the right because we have 3 oxygens. Next, we're going to balance the hydrogens with H pluses. We're going to write down 6 H pluses over here. And then finally, we're going to balance the charges with electrons. We have 0 on the right side. We have a -2 here and a +6 over here. So that's a +4 total. Well, how can +4 equal 0? We need a -4 on the left side. And that's a balanced half reaction. We're going to start all over again by putting in the N2O4 yields NO3 with a 1-. Okay, we need to balance everything other than hydrogen and oxygen. Well, we have 2 nitrogens and 1 nitrogen, so I'll put a 2 in front. Now we're going to balance all the oxygens with water. We have 4 over here, and we have 2 times 3, so 6 over here. So we need 2 more on the left side. So we're going to put down 2 waters on the left side. Now we're going to balance all of the hydrogens with H pluses. I have 2 times 2, so that's 4 over here. So I'm going to put down a 4 H plus on the right. Now I need to balance the charge. On the left, that's a 0, that's a 0. There's 2 times -1, so that's a -2. And it's a 4 times +1, so that's a +4. So this is a +2 on the right side. It's a 0 on the left side. How do these equal? I need to add 2 electrons on the right side. So come up here and put down a +2 electrons. Now I have my second half reaction balanced. Are the electrons on opposite sides? Because if they're not, I totally goofed up. They are, and therefore I need to have them canceled. So I'm going to cancel them and add the 2 together. Well, 2 doesn't cancel with 4, so we're going to multiply the bottom one by 2. I know both my examples, I've multiplied one of the half reactions by 2, but sometimes it'll just work out. Sometimes you'll have a 2, 3, which means you have to cross multiply. Sometimes they can be quite large, so they just have to cancel. You could multiply both half reactions by different coefficients to make them cancel. So I'm going to multiply this bottom one by 2 all the way across, and they'll cancel out. So if I do that, I'll have 4 waters, I'll have 2 of the N2O4s, I'll have 4 of the nitrates, I'll have 8 hydrogens and 4 electrons. Now, let's see what cancels. I got 4 electrons and 4 electrons. I have 6 hydrogens with 6 of my 8, leaving me 2. So I got 2H plus. 3 waters will cancel with 3 of the 4 waters, leaving you 1. So I have water on the left, just 1, and then everything else just comes down. We need this for stoichiometry. So in stoichiometry, we're going to go from moles of A to moles of B, and we use coefficients right here to do that. So the whole purpose is typically to figure out the coefficient of one reactant to the other reactant. So now this is a 1-2 ratio, and we'll do a titration.